Here we go again. It's called Special Relativity, Moving Goalposts, Clock Hypothesis. Einstein's special relativity theory is presented by him in 1905 as based on two postulates. By postulates would take to mean assumptions, but as well as these explicitly stated assumptions, there becomes a need to add an extra assumption. Now I assume you know what the postulates are. They're talked about a lot there, the principal relativity and constancy of light speed. So now this is as per Wikipedia. It's the clock hypothesis, and according to this, it's the assumption that the rate at which a clock is affected by time dilation does not depend on its acceleration but only on its instantaneous velocity or speed. This is equivalent to stating that a clock moving along a path P measures the proper time defined by this equation. The clock hypothesis was implicitly but not explicitly included in Einstein's original 1905 formulation of special relativity. Since then, it becomes a standard assumption and is usually included in the axioms of special relativity, especially in the light of experimental verification up to very high accelerations in particle accelerators. So basically the clock hypothesis is an extra assumption. It's kind of like the third assumption. It used the wording implicitly, so Einstein is not stating it. He does not state the clock hypothesis in his 1905 paper on special relativity. Instead, you have to interpret Einstein as meaning the clock hypothesis. So now we look at the reason why a third assumption has to be added to special relativity. Right, these are the Laurence transformations, the usual maths that are used in special relativity, and you're having coordinates t, x, y and z, and also have the coordinates t prime, x prime, y prime and z prime. And special relativity deals a lot with how you connect these things. You note here that you have a speed v in there and there's no acceleration term there, it's only just speed v. So you have a speed v but there's no acceleration. Thus, special relativity is not deemed as dealing with acceleration effect on time dilation. I'd like to make a note that personally I don't like the term time dilation. I prefer calling it clock dilation. So the clock hypothesis counts as an additional assumption to the two that are explicitly stated by Einstein in his 1905 paper. The problem that was faced was reconciling special relativity with general relativity. And one way of talking about the difference between these two theories is to say that special relativity doesn't deal properly with acceleration, whereas general relativity does. So when you give the special relativity time dilation equation, it's only speed involved in that equation and not acceleration, i.e. special relativity deals with speed v but not acceleration. But of course some have attempted to modify special relativity to include acceleration. But for now, just going with the modification of special relativity of adding the clock hypothesis as a third assumption to special relativity, what you're basically doing is moving goalposts. you've got two assumptions explicitly stated by Einstein, and then you've got to say, well, you've got to add another assumption to it, even though it's implicitly in the paper as something you can interpret as a third assumption. Really, it's still moving the goalposts. So, as Wikipedia explains, moving a goalpost is an informal fallacy, in which evidence presented in response to a specific claim is dismissed and some other, often greater evidence is demanded. So in this case of special relativity, the goalposts are being moved. You're supposed to be starting with two assumptions, but that's not good enough. You suddenly then have to add a third assumption to it. And talking in terms of football, if you're trying to score a goal and somebody moves the goalpost out of the way, that's cheating. And basically, special relativity seems to be cheating a bit. It will add extra assumptions when it feels a need to, such as the clock hypothesis. And the note is to not have added the clock hypothesis to special relativity and instead try to add acceleration to special relativity, and that would be a different modification and hence a different moving of the goalposts. So now this is Karl Popper. He was an very influential philosopher of science, and a lot of people go by him. By Karl Popper, you expect to be able to test a theory, but when move goalposts, you can't test the theory, and that's the whole point of why moving goalposts is supposed to be a fallacy. You want to be able to test a theory, because if you're moving goalposts, then the theory becomes a moving target. It's not a fixed target. It might make some claim, but then the goalposts are moved and it makes some other claim. You've not got some definitive claim which can be tested. Instead, you've got something that can be modified to make different claims, lots of claims. So you just have to accept that special relativity is not a fixed theory, and it's just something that is just get added to and modified ad hoc. And I gave two examples. You could add the clock hypothesis to special relativity and modify it that way, or you could not add the clock hypothesis and try to add acceleration to special relativity. So you've got lots of ad hoc modifications you can make. And this is the point I will emphasize again in later videos when I point out other modifications of special relativity. Karl Popper, influential philosopher of science, believed that a scientific theory should be able to be put to a test and potentially be falsifiable if making wrong predictions. Unfortunately, we have to accept that special relativity is not that type of theory. It's not that type of theory now. What it was in 1905 is not really that clear, but people have modified it, and modifying it means moving the goalpost. Extra things are added to it and it gets modified ad hoc, i.e. special relativity is not a proper theory. It makes no definitive prediction and just keeps getting modified in different ways. Finn, thank you. And other videos will now point out the other moving goalposts. Thank you.